Dear Professor, my topic of paper is photorealistic single image super resolution using a generative adversary network. Shortage name is sRGAN. And this is the author. And my name is FuRui. And this is my outline. I have 7 steps want to explain about this paper. One is introduction. And second, I want to talk some method and model. And the first part is the most important part that introduce about how the loss function does. And the next step is that the experiment I do already and the new idea and finally give my conclusion. And in the part of introduction, we all know that GAN is very popular in recent days, but it has some weakness about uh, generated image. Sometimes it's not very good. So SR can solve this. Sometimes can solve this problem. The main purpose of sRGAN is to convert a low-resolution picture into a high-resolution picture. And this is a method that how we use sRGAN to solve this problem. And in the right side is the original picture. We put it into the low uh, resolution picture as an input and use the algorithm of sRGAN and get the result of it. And finally, the output is the same as the original picture, and sometimes it looks better than original one. And in this method, we have two datasets. One is the original picture mix dataset, and the second is after the high definition picture process to low resolution picture become the second dataset. And in this method, we use two datasets to train the network to achieve the conversion of low resolution to high resolution images. And this is a model that in generation network, we want to produce a low generation picture. And in discriminator network, we want to make sure whether this whether this image we produced is real or wrong. And this is the explanation of generator and discriminator. In this part, the generated network part contains multiple residual blocks. Each residual block contains about 3 multiply 3 convolutional layers. The convolutional layer is followed by a by-bit normalization layer and p-ReLU as activation. As a function, two multiply subplex convolution layers are used to increase the feature size. And in the discriminator, the network contains about 8 convolution layers, and the number of network layers depends the numbers of features increase and the size of features decreases. The activation function is selected as ruler finally, it obtained by two-fold connected layers and the final sigmoid activation function. And this is a main part of this paper. It has it mainly introduced about loss function. In the loss function of a generation, we can say that it contains about content loss and adversary loss. In the content loss, it mainly include about miss loss and weak loss. The miss loss meaning about minimum mean square error in Pelix space, and weak loss is the main part of this paper. When they put picture 4 times or 5 times bigger, uh, in the normal method, sometimes it looks smooth and sometimes the picture looks not so clear. So in this paper, we add the white gloss to make the paper make the image we produced more clearly than before. When we put the picture as 5 times as before, we can see that some lines in the picture that makes the picture looks more clear. And um, in the adversary loss, we can see that the loss of the generated part defined by the GAN model, and in this part we can say that if we find that the uh, the after generation generated the picture and when the discriminator function find it near the real picture, the loss function will become uh, next to 0. So this part is to makes the minimize of the difference between the output picture and the real picture. And in this part, we can say that in discrimination, loss function have two meaning parts. One is adversary loss, and the second is content loss. The adversary loss pushes our solution to the natural image. Many faults use a discriminator network that is trained to difference between the super's resolved images and the original photorealistic image. And the content loss function motivated by principal similarity instead of symptom in Pauli's space. And this is the experiment that useful method to get the result. We can, if we put the picture big enough, we can see that use sRGAN produce the result looks clearly than the other method. But sometimes it has some weakness. At the last line of the woman, we can see that sometimes we produce the picture uh, have some weakness that not looks like the real picture. But almost all the time, sRGAN produces the picture more clearly than the other method. And this is also the experiment that we want to do, is that we put the low resolution picture as an input and output the right one. We can see that the right one uh, really looks clear than the other than the input manage, and we put it big enough, and we can see that some clearly line on the man's face. So use this method, it may produce some line on their face and makes their picture looks more clearly. And this is the experiment main part of the experiment. At the time limit, I have not finished the whole experiment, but as a next step, I want to do some trying to finish the experiment. And this is a conclusion that in sRGAN training data have 3 parts. The GT means the original picture, and the train data means after processed the picture of the original picture. So the output is the picture of the final resolution of high resolution, and there are two meaning part of the paper. One is a SRR recent was trained, and a high-resolution image was restored by ResNet. And then this image and JT were transferred to the WIG network to train a message loss to be minima. So in the loss function part, the WIG loss is the main part of this paper to look the output of the image more clear. And the second part is redesign of the loss. We combine the mass loss of the feature map with the loss of the unanswered network. This is the main part of this paper. And there are two conclusions in this paper. One is that when we super resolution the picture, we can still reflect the detail after being enlarged 4 times. And the second is that it can better restore the problem of low resolution, combining the high-level feature loss and the resistance of the network loss to get a better restoration result. And this is my new idea, and the original intention of reading this article. We can see that sometimes the uh, original picture of a dataset cannot easily to find in the dataset. So maybe this is the weakness of this method. I think in my next work, I should try to find the original picture easier. Maybe we can cut the resistant image date and then use a cut small beach image as the original picture for training. And this is my presentation. Thank you.